Welcome to the Microbiome Report, powered by BIOHM Health. I'm your host, Andrea Wien, and today we're talking about helminths. I know. I had crickets a few weeks ago, and now we're talking about worms. But stick with me. To start the show, I want to do something a little bit different. I want to read you some of the reports from people who have taken these helminths and are reporting their change in symptoms. So this first one is from someone with Crohn's disease. They say, 1 year ago, I was ill and hospitalized. I could have died if I'd kept going the way I was going. I researched hookworms for 6 months and decided to go for it. I am now living a normal life, living each day happy and healthy. I honestly believe the worms saved my life. The next one from someone who had struggled with asthma and allergies. They say they're free of asthma and allergies for the first time in 12 years. Someone else who was dealing with gut dysfunction. Gut-wise, I feel better than I have in many years, including when I was on a strict SCD, that specific carbohydrate diet, for 2 years. And then another person reporting improved memory. I'm finding that I have a much improved memory. My thoughts are clearer and sharper. I'm in less of a fog, and I'm retaining more information and able to recall events from the past that I had forgotten. Really incredible. I spent some time reading through the other reports on the Helmuth wiki page, which we'll link to in the show notes, and I'm just blown away. That's not to say that there's not some risk here. This is not a cure-all by any means. This is not a National Enquirer article, helminth worms cure everything. There are certainly conditions that this does not work for, people this does not work for, and none of this has been FDA approved. This hasn't been studied in a clinical trial. So take everything that you hear today with a grain of salt, but there is such promising research to be done in this area. And my guest today is Dr. William Parker. Dr. Parker has studied biochemistry and immunology at Duke University since 1993. He is best known for the discovery of the function of the appendix, which is a safe house for bacteria. And he's spent the last 15 years looking at the fundamental cultural causes of inflammation in Western societies. His work on biota alteration, a concept which evolved from the hygiene hypothesis, which we'll talk about on the show, has led to the discovery that intestinal worms, called helminths, are very supportive of healthy neuropsychiatric function in adults and in children. He's published more than 120 peer-reviewed papers on intestinal worms and their benefits on human health. Today we're talking about what helminths are, the concept of evolutionary mismatching. We're also talking about the conditions that helminths are helpful for, which ones maybe they haven't been as helpful for, and how these intestinal worms interact with the rest of our microbiome, the bacterial and fungal communities that are living in our gut. We talk about how people administer them, how to get rid of them, and why this is such a big piece of what we could be missing when we're talking about gut health. Enjoy the show. Dr. Parker, thank you so much for joining us.
It's a pleasure to be here. Thank you very much for the invitation.
So I'm just going to apologize to our listeners, those who have heard me before. I have a little bit of a cold going on today, but I did not want to push this call with you because I was so excited to talk about this. So I apologize for anyone who's listening to my scratchy voice. Hopefully it won't be too distracting. So to start, let's just jump right in and say, what are helminths? That's a term that I wasn't familiar with until quite recently, and I'm sure a lot of our listeners have no idea what that even means.
A good general definition of a helminth, and when we say helminths, it sounds like a football helmet, but it ends with a TH. So a helminth is, by a good definition, would be an intestinal worm. They fall into two main categories. There's flatworms and roundworms.
Okay. And now we're talking today about how these can really help modulate the immune system and potentially, I hesitate to use the word cure, but really help with the symptoms of some different diseases. But, people who maybe have seen functional medicine doctors, who have seen even conventional doctors, have heard worms cause diseases, right? We shouldn't be inoculating ourselves with them. These are things that can really make us sick. So what's the difference between what we're talking about today and the worms that people may be on anti-parasitic protocols for?
That's a very good question. If you look in any biology textbook, you'll see that helminths or intestinal worms are absolutely 100% classified as parasites. In parasitology books and all kinds of medical related books, they have that classification. And a parasite is something that just harms the host and derives benefit from a host. That thinking has proven to be very problematic. We now know that our immune systems are adapted to or sort of expect to find some worms and protozoans or protists in our environment. And when we don't find any, none at all from the time of birth, then the immune system gets a bit dysregulated. So the point is that if you look in a biology textbook, you're going to see information that is simply not correct.
I think that when you talk about that, I immediately jump to bacteria, right? We talk about this on the show for so long, germs and bacteria, where we have to kill them all. We have to get rid of them all. And now we've really come into understanding that, yes, when there's too many or they're out of balance with each other or with the fungal communities in our gut, we see issues, but we need bacteria to live. And I think that this is where we're starting to get with these worms as well, right?
I would agree with that. The issue with bacteria is that humans, when they realize something is killing my friends or my neighbors or family members, then that thing becomes the enemy, right? And of course, we now know there's a huge difference between, say, a bifidobacteria in a yogurt versus a salmonella that's on the turkey that we should not have thawed at room temperature, right? But they're all bacteria, but there's some good ones and some bad ones. And by the same token, they're all helminths, but there's some that are not nearly as helpful as others.
Okay, I do want to jump into which ones we're using in therapy and which ones are helpful. But before we move on from this point, I want to talk a bit about this hygiene hypothesis and how that's really been proven at this point. And then what you study, which is this concept of evolutionary mismatching.
The hygiene hypothesis, it's an old term cooked up in 1988, and then really major step in development with that term occurred in 1989. And it's been transformed and tested and changed over the ensuing decades. So it's no longer a hypothesis. It's more of a working model or a paradigm. You could call it a theory. We do call it a theory in our scientific writing now. We call it biota alteration theory. And biota is just the life associated with the ecosystem. We've altered the life associated with the ecosystem of our body, and that has consequences. Another way of describing this, I think one of the best ways that we've been able to convey this in the scientific literature is to talk about something called an evolutionary mismatch. An evolutionary mismatch just means that when you have evolved as a species under a certain condition and then the conditions change, you might get sick. So a classic example would be what would happen if we take a fish out of water. So we know that fish have evolved in water. When we take them out of water, they're just not going to be very happy. So a fish out of water is another way to describe this current model of biota alteration theory, where we've changed the conditions in our environment, which is making us sick. Another good example is the food that we eat. I'm sure you and your audience have talked about that a lot, with a lot of processed high-fat foods that we could never have encountered in nature. We have a hard time resisting those. We eat too much. It doesn't do good things to our body, and it can make us sick.
Absolutely. And in terms of what we're talking about today, I mean, really, the whole basis of this is based on we now have toilets, we now have sanitation, people are living in cleaner environments than they ever were before. And so we're not being exposed to as many of these parasitic worms or protozoa or whatever might be out in our environment. But our immune system really co-evolved to have these things around. So now we're getting sick because our immune system is expecting to find them, and it's not.
That is correct. I think the bored teenager hypothesis is really good too, where, if you don't give a teenager something useful to do, they might find something bad to do. Our immune systems could be viewed that way. You've taken away their natural interactions. They don't have anything to do in a way.
Now, I've heard you talk in the past on another podcast about this really being prevalent when we had outhouses where people were walking around without shoes and, maybe there was some fecal matter on the floor and worms were, entering through the heel of someone's foot, let's say. But what about in hunter-gatherer communities? Would helminths also have been prevalent then, or was this something that really didn't come to be part of our evolutionary story until an agrarian society?
The part of the evolutionary story that we're talking about probably goes back about 400 million years. So this would be when our ancestors were just sort of departing from, they were getting jaws, let's put it that way. So they're still in the water, they're still fish. It's much older than humanity. If we look at other kinds of hunter-gatherer species, so for example, if we look at some of the apes and old world monkeys, they have helminths. It's not just looking at other species and it's not just trying to track down current hunter-gatherer populations. It makes sense if you look at it from a lot of different angles. So for example, it's not just toilets that are causing the problem, but and I say quote unquote problem because we need toilets. It's not that we want to undo civilization to reverse the problem. We need to artificially fix this problem. But it's beyond toilets. It's the fact that we wear shoes. And I live in a house now which is essentially free of insects. It gets one mosquito in my house and, we're just spending, an hour trying to track that critter down to get rid of it, right? Because it's so aggravating, just one little insect. Insects carry these organisms. They're almost always benign. The helminths and protozoans carried by insects. The ones in my lab are carried by insects. They're very benign. And we've excluded those that, imagine 3,000 years ago where you're living in, say, some kind of house, but it doesn't have any kind of modern windows. It doesn't have good seals anywhere. It's pretty open. You've got insects running around everywhere. And then go back another 10,000 years before agriculture where you're living in caves, right? Or you're living in more natural type dwellings, whatever you can kind of set up from your surrounding areas. You've got tremendous numbers of insects running around everywhere. So it's not just the fecal oral route, right? It's not just walking through a latrine barefoot. That's certainly a very good way to get a lot of helminths, and it's definitely not recommended, but it's probably not the standard way that we got helminths before we developed agriculture 10,000 years ago.
So let's get into that. Which helminths are we talking about? I think people have heard terms like hookworm or tapeworm, or when we're dealing with our animals, we give them heartworm medications, right? So what are we talking about when we're talking about the research that you and your team do and the helminths that you're bringing into this discussion?
That's very interesting. We just published a paper in a prominent parasitology journal looking at the 4 helminths. There's 4 different worms right now that people are using for therapy. Those 4 were more or less picked a little bit haphazardly. They just happen to be available and they happen to be known not to cause too much problems in controlled amounts. That's basically how those 4 were chosen. Nobody's gone out and done a systematic search to find, what all's out there, what would be the most beneficial with the least amount of risk. So those 4 are 2 different kinds of whipworms. You've got the porcine whipworm and you've got the human whipworm. Then you also got the one particular species of tapeworm. Now, not all tapeworms are beneficial. Tapeworm is a very, very broad group of organisms, right? And there's one particular tapeworm that's used. It's the rat tapeworm. It's the therapeutic component of that is known as the HDC. And then, of course, there is the hookworm, which the hookworm is pretty widely known because it does cause disease when present in high numbers.
So we're talking about the same hookworm in small numbers can really help people. And we'll talk about what kind of conditions are most helpful when we introduce these types of worms. But in large numbers, they can cause problems similar to Candida, let's say.
Yes, that is correct. Absolutely.
Okay, great. And then when we are looking at what conditions are most helpful, I can imagine that not a lot of people who are feeling great are going out and infecting themselves with worms. So what kind of conditions are helminths most helpful for? And then are there people or conditions where they're not helpful and they actually could hurt?
Yeah, there's a wide range of conditions where people can be helped. And I say can because, not every case of somebody trying a helminth is successful and beneficial. No clinical trials have been run yet showing substantial benefit. And there's a lot of reasons for that. But there are thousands of people that are trying these things. We have ethics board approval to study the results that people are getting, and we have spent a lot of time, effort, and energy doing that, trying to eliminate different kinds of biases. But still, we're guessing. It's a very, very educated guess, but we don't have a study which proves benefit in any particular case. So that being said, from what we do know, helminthic therapy or helminth therapy is extremely effective for some allergic conditions. It's effective for many autoimmune type conditions. There's some caveats there. Works better for relapsing remitting conditions than it does for persistent conditions. It's effective for some digestive disorders. And what we discovered, and we're very surprised by, is that it can be, in hindsight, we're not surprised, but when we found it, we were surprised that helminth therapy can be very effective for many kinds of neuropsychiatric conditions, such as anxiety disorders, chronic fatigue, and depression.
Interesting. And that obviously ties into what we talk about on this show a lot, that gut-brain axis. So when we're healing the gut, and that's where these worms are setting up shop, right? Can you talk about how they're administered and then where they are in the body once they're living?
Of the 4 kinds of worms currently in use, 3 of them are taken orally. One of them is administered. It was popular to put them on the forearm, but most people have now switched to a more calloused area of the body, which is more of a natural route for the organisms, and they get less of a side reaction. So they're putting them in on the foot, typically.
And then this sounds gross, but burrowing into the skin and then setting up shop in the intestines, correct?
Well, they burrow in the skin. They travel through the bloodstream. They burrow out of the bloodstream into the lungs. Then they're kind of passively transferred. This is going to get even grosser. It'll passively transferred along the mucus, coughed up, swallowed, and then set up shop in the intestine. The transfer through the lungs is probably very important. There's based on the evidence that we have, we think the hookworm can do some things that none of the other worms can. And a lot of that has to do with lung function, and it may probably traveling through the lung has a profound effect on that.
Interesting. So how long does that journey take?
That journey you're looking at I'm not an expert on the life cycle of this guy, but in general, it's several days to get coughed up and then swallowed. And it's still developing and maturing out to 6 weeks inside the intestine.
Now, is there any harm in someone with leaky gut, let's say, so intestinal permeability? So these worms enter the digestive tract, they're finally in the intestines. Someone that has that intestinal permeability, any concern about those helminths getting back out and getting into the bloodstream and potentially setting up in a different organ or somewhere where they could cause more harm?
So the size of the helminths is much, much different than the size of bacteria. So you can physically see even the smallest helminth currently in use, you can physically see it. It's quite a bit larger than the life that lives in our gut in Western society. If you had that much permeability, you would just have gaping holes in your intestine and you would just die from an infection right away. It's best not to think of it as a hose with, say, a fire hose that somebody's poked holes in and water shooting out. Think of it as a fire hose which is made maybe out of a little bit the wrong material, and so water just kind of seeps out of it a little bit. But that doesn't mean if I put a few marbles in it, those marbles are going to stay inside the fire hose. That's there's some water molecules that are going to be seeping out, but nobody's taking an ice pick and jab big holes in it. It's a little bit different than that. That can happen with appendicitis, where the appendix it doesn't just get inflamed, it actually ruptures. That's an extremely dangerous condition. And that's a good example of if there were helminths in there, they could come out, but everything else is coming out too. some helminths, there's one, for example, called Hymenopus nana, and it burrows into the muscles, right? And if the porcine tapeworm or pig tapeworm, it can leave the gut and form a cyst in the brain or cyst in the muscle tissues. It likes to go into the diaphragm and cause pain there. So it's very important to know that some helminths are bad and then some are not. So as long as we focus on the 4 that are currently in use, you don't have to worry about those escaping from the gut.
Now, you mentioned that we know that helminths are more effective in conditions that are reoccurring with flares. So let's say something like Crohn's disease versus something like I have celiac, which is kind of just present, right? And it's managed by diet. And, for the most part, I'm not having, unless I accidentally eat gluten, these kind of extreme flares. Is that what you're talking about when we're saying something like recurring versus omnipresent, if you will?
Yeah. So it's the best data we have is on the condition of an autoimmune condition, multiple sclerosis. So once multiple sclerosis advances to the point where it's persistent, it never lets up, it doesn't remit, then the helminths are not nearly as effective as they are if you catch it when the disease is still up and down. And the same is true, we think, of some allergies. So, for example, with seasonal allergies, the helminths do a great job. A couple of papers published on that in the 1970s, literally from 2 different British scientists working independently. So seasonal allergies, yes, there is a cure. It's been out there for 50 years now, and we just need to capitalize on that. That's a separate issue. But if you look at, for example, something like sensitivity to mold, and if you have mold in your house, based on the information we have, it's likely that the helminths won't do any good. If you have, say, allergies to a cat, but you have a cat in your house, the helminths might not do you any good. But if you, say, didn't have a cat in your house and just had an occasional contact with a cat, the helminths might help alleviate the symptoms that you experience when you do contact that rare cat that happens across your lap one day when you're sitting at a friend's house.
Okay, that's so interesting. So what about in the case like myself with celiac? There have been periods where I haven't eaten gluten, but perhaps I have more brain fog or, just some more, again, going back to that gut-brain connection, some more like mental type symptoms. Would helminths be something that might help with that?
I think so. We don't have a lot of data on celiac. And I think a lot of the reason, or part of the reason, may be that people with celiac do control their condition well with diet. Motivation or the temptation, however you want to look at it, to try helminthic therapy is probably less. It never has become popular, there may be a good reason why it hasn't become popular, because a few people that have tried it just didn't experience anything or no beneficial effect. So they never wrote about it. They never told their friends, and it just never caught on. That's speculative. I don't know that. I do know that we don't have a substantial amount of data on that. I think there are certainly cases where a mental fog kind of condition has been helped with the helminthic therapy, and profoundly so.
Now, is there any research that you know of that helminths actually can improve gut absorption?
So that's an interesting question. In the scientific community, those of us working with the biomedical research field focused human health, looking at gut absorption is not something that it's not sort of a standard, or looking at leaky gut also is not really a standard thing that we do. There's no animal models for that. It's not a popular type. And certainly there are some folks working on it. It's just not a standard thing. We'll look at the microbiota, we'll look at the behavior of the laboratory animals. Those are more standard tests. Looking at absorption and looking at leaky gut, those are more specific and not necessarily popular for evaluating the effect of your therapeutic.
Mm-hmm. Okay. Yeah, that makes a lot of sense. I'm also thinking too that, if this can help with things that are kind of on and off, like seasonal allergies, could it be beneficial for people who want to prevent disease or prevent autoimmune disease or prevent seasonal allergies? Would this be something that they could take preventatively, or would it suppress the immune system too much?
That's a good question. When we started looking at the effect of helminths on the body in our laboratory animals, we assumed, well, because it takes away this autoimmune disease in these laboratory animals, then it must be immunosuppressive, right? Because we're biomedical researchers. This is what we do. We look at blocking disease using immunosuppressive drugs. And what we found is that helminths just don't work that way. They are not immunosuppressive. If you come from the background of biomedical research and the pharmaceutical approach to treating disease, this creates a bizarre kind of paradox. We've never seen anything before that would take away an immune disease without immunosuppression. How is this possible? But then if you think about it from the evolutionary medicine perspective, from the evolutionary mismatch perspective, and looking at the biology of the situation, you see that, well, it's not immunosuppressive, it's immunoregulatory. It's actually fine-tuning that system. I love analogies, and a good analogy is just tuning your car, right? It burns less gas, but it will go faster. So if you come from a background where the only thing you can do is just regulate the gas flow using crude measures, and you're not really tuning the engine of your immune system, it's just kind of a surprise when you can actually get a good effect and treat a disease without having to suppress the immune system.
The Microbiome Report is brought to you by BIOHM Health. Do you have a passion for gut health and want to change the lives of others? You could become a Biome ambassador and start making a difference today. Biome ambassadors are smart, health-conscious, social entrepreneurs who get to work on their own terms, earn rewards, and make real money. To learn more about how to become an ambassador and hear from other ambassadors in the program, head to biohmhealth.com. It's BIOHM Health.com. Now back to the show.
So let me ask you this. You're generally healthy. Have you done any helminth therapy on yourself?
Well, so the official answer is no, I don't do that because I study it, right? And if I would be, say if my wife or I had a horrible autoimmune disease, then I would be faced with a dilemma, right? And if I do the helminth therapy myself, I'm supposed to stay agnostic to the types of helminths they are and what effect they might have, and try to compile all the data together. So it's not the best idea for me to engage in the therapy. But back to your question, do I think it's just generally healthy? The answer is almost certainly yes, but we don't know enough to know exactly what would be healthy and, how much would be too much. Or if you just look at patient well-being, not even patients, people that are not sick, if you look at well-being of a person, if everybody had 3 hookworms, would everybody be a little bit happier? And I think the answer is probably yes, but I don't know. If they had, 10 rat tapeworms every month, would they be happier? I think the answer is almost certainly yes, but we don't know. It's not something we would say, oh, I'm sick, but it's just we're not as well as we could be because our immune systems in Western society are at a chronically unhappy state.
Yeah, it just makes me think, I just had a baby not too long ago, and so everything now is run through the lens of, what's best for him. Just thinking of, is there a benefit down the line, in 10, 20 years when we really know so much more about these, a benefit to infecting ourselves when pregnant or, giving our babies host worms from the time they're born? Is that really going to help to prime the immune system and teach it in a way that we've lost, I guess I should say, in modern day society?
Absolutely. In fact, our laboratory animal models, what we find is if the mother has helminths when she gives birth, then those now we don't give the babies helminths until they're weaned, but at the time of the birth, the babies, because they grew up inside the mother's womb in an environment that had helminths, those babies have a brain that's protected from nonspecific inflammation. And you can see long-term effects of that throughout the life of the baby. It's telling you that when you take an organism such as a human being and you completely change the ecosystem of the gut in ways that we didn't even realize we're doing, it has an effect that can be far-reaching. Going back to my assertion about, I think it probably would be healthy for everyone. And we don't know what we don't know because none of us have ever had helminths.
Well, and I think there's probably an interesting discussion to be had, which we don't have to get into too much here. But if everyone just had a couple of worms, suddenly maybe allergy medications are not as useful or necessary. There's a whole pharmaceutical industry that's really built around treating so many of these symptoms that potentially we could see a massive decrease in if we started using helminths more regularly.
Absolutely. Right now, 43% of our children are on medication for chronic conditions. 40% of us have allergies. 20% of postmenopausal women have depression. It goes on and on. We are becoming a pharmaceutical society. I think we need to get back to the underlying problems causing those diseases, and certainly loss of helminths is one of them. It's one out of probably 4 or 5 big ones. If we deal with those fundamental problems causing disease, then yes, we can get off of the pharmaceuticals, which they're obviously expensive. They're also carry side effects with them typically.
Yeah, and even just reading through, you gave me a great resource to look into, which was the Helminth therapy wiki page, which we will certainly link to in the show notes for everyone who wants to check that out. But so many people on there giving their anecdotal experience saying, I've been on medications for a number of years, sometimes decades, and, using these helminths allowed me to, if not get off those medications, then at least significantly decrease my dosage.
Helminth Wiki, I believe they do a very good job maintaining that site. The challenge of that is most people who have an unusual or odd experience, they want to talk about it because they're very interested in sorting out what's going on. But there's a phenomena that we've definitely encountered in our research of when somebody gets their solution, they're essentially fixed. For practical intents and purposes, they are cured. They don't go out often and get on the social media. They're less likely to get out on the social media and promote what they're doing, especially in cases where they might be worried that if their supplier gets too much publicity, a regulatory agency might shut down their supplier. That's been a problem with that traditionally in the past, at least as far as concern goes.
Yeah, it makes me think of like raw milk. There's so many people who drink raw milk and have, great experiences, but we hear about the one case that made someone sick. And similarly with the regulatory agencies, people are hesitant to talk about the farmers or farms who are supplying that. So there's a lot of parallels to be drawn there.
Yeah, it sounds like exactly the same story all over again. Yeah.
Mm-hmm.
Okay.
So let's talk about the actual microbiome as a whole in terms of these intestinal worms. So do we know how the helminths are interacting with our bacterial and fungal communities that are in the gut?
Most of the work has been done looking at the direct interaction between the immune system and the helminths. So there's been a few papers, and we published one of my colleagues in the Czech Republic, Katka Žurku, published the same study, but with a different result. And that's interesting to talk about. But the bottom line is there is an effect of the helminths on the microbiota. We don't really understand the importance, if any, of that effect. It could be a fairly direct effect. Say the helminths are using some food that the microbiota would normally use. So that just changes the ecological space for the bacteria. Or it could be that the helminths are interacting with the immune system, which we know is the case, but then those interactions with the immune system could affect how the immune system interacts with the bacteria. So it could be a very indirect effect, and it's probably both, but we don't know that. That's a tricky one. We published a study fairly recently looking at the effects in laboratory animals of adding helminths, then examining the microbiota or the bacteria. There was a huge effect. 20% of all the bacteria were different after you added helminths. But then a study by my colleague, identical study, it looked identical on its surface. If you read the paper, it looks identical. They got a completely different result. But if you dig deep, you find, well, their rats were fed a completely different diet than our rats. And plus, they came from a different breeding facility. So they just didn't have the same bacteria to start with. That's a nice case where it probably depends on what bacteria you have, whether or not the helminths will affect that bacteria.
Well, and we know just from this show and talking to different people around the globe that, someone who lives in Missouri has a completely different microbiome than someone who's in Mozambique, right? And even someone who lives in northern Missouri could have something completely different from southern Missouri. Or we did a show with identical twins where they lived in the same house. So you can't get much closer than that, right? Two identical twins living in the same home. And they had up to 50%, I believe it was, different microbiomes when they did their tests. So it's just so wildly different that you could argue, even in the same laboratory, if you're not keeping those conditions very controlled, that those rats could pick up different bacteria just from the people who are handling them or, whoever's on shift that day.
Right. Now, one interesting thing that we're fairly confident about sort of goes the other way, how the bacteria can affect the helminths. So a lot of people say somebody's treating chronic sinusitis with helminths. We received a number of reports on is if someone takes a lot of probiotics, it sort of dampens down the effect of the helminths. So you lose some of your effectiveness. And what we think is going on there is the probiotics are flooding the small intestine, kind of shutting down or tightening up those junctions, making things less leaky, which decreases the communication, the biochemical and cellular communication between the helminths and the rest of the body.
Interesting. So this is a case where a little bit of intestinal permeability might be beneficial?
That would be consistent with the observations.
Okay. Very interesting. Now, are there different levels? I know you mentioned you don't get in too much to intestinal permeability, but that lends the question or begs the question for me, are there different types of intestinal permeability, perhaps, one caused by a diet of highly refined carbs and sugar versus one that is just enough that's allowing these helminths to modulate with our immune system?
Yeah, I think that's a great set of hypotheses you could develop around that. Possibly test them out in laboratory models. Certainly much easier to look in the laboratory models than it is in humans because you can control the conditions pretty well in the laboratory animals. Yeah.
I just need to find a scientist to test my hypothesis.
Well, so the big challenge is to find the scientist who can get funding to test your hypothesis.
Yes,
I bet there's a lot of scientists would love to test your hypothesis, and myself included.
So let's say someone's listening to this show and they think, oh, I have seasonal allergies or worse, I have Crohn's disease and none of the things that I have been doing have really brought me to the level of health that I want to be achieving. How are people getting these helminths? You mentioned there's some labs, some people, there's a little bit of an underground scene here, but this isn't an FDA-approved therapy. So when people are wanting to do this, are they doing it themselves? Is it important to get a doctor involved? Are doctors even allowed to be involved? What does that picture look like?
Yeah, the main limitations right now with trying helminthic therapy are the cost, especially the cost of getting the most benign helminths.
Which would be which ones?
Those would be the porcine whipworm. It's also known as TSO. And it's not an underground actually. There's a company, they sell a product. They produce it in Thailand. It's registered there. It's an Asian medicine. It's Tanavisa is the name of the company. There's also a clinic in Mexico you can go to to get the other organism, the HDC, or you can buy that produced by a company called BIOHM Restoration in England. So you've got a lot of different options there. They're not underground, but it's not the same as going down to the store and buying a Tylenol. Right. The clinic in Tijuana, Mexico has a great reputation. That's called worm therapy. But again, it's about time and money. And by the same token, some of these organisms can be easily cultivated at home. And I say easily, it's a lot of work. You don't run a big risk of failure, but you do have to commit a lot of time and effort and energy into it. A number of people are taking that approach, especially with the rat tapeworm. That's the other fairly benign one. But the rat tapeworm or the HDC and the porcine whipworm or the TSO, those are not going to be cheap.
And are there certain hookworms, like let's say someone who has Crohn's, is there just a helminth in general that we know works better, or is it really dependent on the individual? So they might have to try 2 or 3 or even all 4 of the different types before they find something that works for them?
Most people are picking their type not because they're trying to select the worm that fits the disease. And there's some of that. I mean, the HDC tends to work faster for neuropsychiatric stuff. For ulcerative colitis, the human whipworm or the TTO seems to work better, although you can have adverse reactions to that worm, certainly. There's a well-known case study by an investigator named Ping Lok looking at that particular worm with that particular condition, the human whipworm with ulcerative colitis.
Now, when you talk about adverse conditions that could pop up, what are we thinking? What are we talking about?
Well, for the hookworm, colonization is known to cause fatigue, gastrointestinal pain, can cause joint pain in high doses. It can cause anemia. And that typically happens at very high amounts of hookworm. But some people can be affected by low amounts. Everyone's different. It's pretty rare that just 5 hookworms would cause a lot of problems, but it can in some people. The worm we were talking about earlier, which was the human whipworm used for ulcerative colitis, that one can make the condition worse in some cases. But usually, in general, you get no improvement or you get substantial improvement. So back to your question, how do we pick a worm? Well, most people pick a worm because it's based on what they can afford. The hookworm is going to be the least expensive, but it has some disadvantages. It's not as benign as the TSO and the HDC.
So if someone does get these worms, and I want to talk a bit about dosing and how to decide how many worms you should be taking or, putting into your body. But if someone does take these, how long can they expect maybe to have some adverse reactions before they might see benefit? When do they need to say, okay, I need to get rid of the worms because they're definitely not working for me, versus this is a period where everything's just kind of getting sorted out?
Here again, it will depend on which worm that you take. And it also depends on the individual. So based on the studies we've done, regardless of which worm you're talking about, there's probably a 10-fold range of effectiveness in the population. You take 10 different people, and one person might need 5 worms, and the next person might need 200 worms. That's, say, for example, for the HDC, or someone might need 5 hookworms, or somebody else might need 100 hookworms. And 100 hookworms would be a lot of hookworms. Almost nobody needs that much. But you'll find a person that does need that much. Just something about their gut physiology or their immune system in general is different. Given that, what most people would like to do if they can is start out at a very low number and slowly work their way up. Working your way up with a hookworm takes a long time because you have to wait for up to 3 months just to see what the first dose is going to do. And then, you might be almost 2 years into it before you really know if the therapy is going to work well or not.
So are there practitioners that are well-versed in this that you can work with, or is it kind of just keep going until it gets to be too much? How are people really finding what the right dose is for them?
A typical physician is not paid to know, every new therapy that comes along that's not FDA approved. It's just not their job. So you asked me earlier, and we just didn't get to it. How do physicians deal with this? And they're not allowed to recommend therapies that are not FDA approved. There are some physicians, but they're fairly rare, who are very, very familiar with the therapy. They still are not supposed to recommend it, but certainly if they're knowledgeable, they can give the patient information. And just as I'm giving you information without making a recommendation, this is what we know. These are the chances, with worm X or worm Y or Z or of a good reaction versus a bad reaction with a given condition.
And then I think what also might make people feel a little bit better about this is they're easy to get rid of, right? It's not like you give yourself these worms and then it's a long process to extricate them from your body if that's necessary.
Right. You can get rid of them quickly. Now, and of course, going back to the issue we were talking about earlier, sometimes if you have a bad reaction to a helminth, then that can linger for a long time, even after you've gotten rid of the helminths. Of course, it's rare. We don't know how rare because we haven't done a large-scale FDA monitored study, but it can happen. So There's a lot of unknowns in this. It's not absolutely risk-free, although if you're a patient who has a debilitating condition and you're not getting help anywhere else, it makes sense for most people looking at the data objectively to give it a try, knowing that it's not risk-free. And again, knowing that the more expensive worms have less risk to them. They're more expensive because you have to take them regularly. They don't last in the human body, and because it requires a lot of work to cultivate them.
Yeah, that was actually something that I was thinking about too in terms of this dosage, in nature, in past societies where we would be getting helminths all the time, they would be repopulating. But here, it's really taking a while for us to get the dosing sorted. When people were infected, let's call it in the wild, they would just have these worms, right? So why is there a discrepancy, do we think, between giving them to yourself now versus just picking them up in the wild? Was the immune system modulating that in a different way where we were exposed to them all the time?
Right. So it's a much different scenario if your mother had them when you were born and then you began to pick them up early on, especially around the time of weaning. Everyone knows, for example, if you travel to Mexico, don't drink the water. Now, everybody in Mexico drinks the water just fine, right? But if they were exposed to it from a very early age, and even they're in utero, their mother was exposed to it, so that affected their immune function in utero. It really is a much different, prevention is better than a cure. And our immune systems are fragile in the West, and to a large extent compared to probably what they were before the hygiene era. We just have to work with it from where we are. And it's, as you pointed out, it's not the same as if, we were born with it.
To wrap up here, what are the questions that you're continuing to ask? What does your research look like in the next couple of years? And, what can we look forward to in learning more about in terms of the helminth therapy?
Well, there's a lot of questions that you're asking me that I can't give you satisfactory answers for, and I would love to. For something like celiac disease, which helminth is best? Do helminths have an effect? What kind of effect do they have? Could it prevent celiac disease? All those kinds of things. That's kind of, people are still collecting data on that. Helminth Wiki is a great source to see, what's the latest on that. There's still suppliers. There's a couple of suppliers, Jasper Lawrence and Gary Nagletti, that have been at this for, more than 10 years now of selling these helminths. So it's ongoing as far as people trying this. And I would love to have more data from that. But in reality, we need to get it to go mainstream. We need to do those clinical trials. We need to create a product that's stable, that's cost effective, that doesn't cost you $4,000 or $5,000 in shipping just, to get as much as you need every year. That's ridiculous. Or it doesn't cost you $15,000, and insurance is not paying for any of this, right? It doesn't cost you $15,000 to get the porcine whipworm that you really need to treat your Crohn's disease, right? So we need to move that forward. That's the bottom line. And get this out of, it's not, I wouldn't call it in the shadows, but it's certainly not in the mainstream.
Yeah, I think this is probably the first time that most of our audience has heard of this. And certainly I had heard of it peripherally, but not in any significant way until I heard you on a different podcast. So we're so excited that you are tackling this and sharing it with us today. And I'm excited to see what comes up next. So thank you so much for the work that you're doing. You mentioned the wiki, and we will link to that. I know we had some issues linking in the show notes previously, but I will make sure that that wiki helminth therapy link is in the show notes. Dr. Parker, any other resources that you would recommend?
Well, there's general reading on the helminths. We have it on we have a WordPress site, sort of a blog site, williamparkerlab.org. We have general information about helminthic therapy there. It's more along the lines of why we believe that we do need some helminths and some of the challenges in trying to get these things through a drug pipeline when it's very difficult. You can't patent a helminth, right? So there's some hurdles which face helminthic therapy that don't face regular drugs. And I think though that makes for a lot of interesting reading for people who are curious. It's not necessarily going to help them to know, if they have a condition, what do they want to try? And again, a lot of that's going to depend on cost and availability for the patient.
Okay. Well, thank you so much for the time today. We really appreciate it. Looking forward to hearing more about the research that you're doing and that other people are doing. And hopefully this will be mainstream soon. So thanks so much for joining us.
Thank you very much, Andrea. It's a pleasure talking with you.
As always, thank you so much for listening. Like I mentioned in the show, we did get some feedback that some of the links were not showing up. We'd been missing putting them into the show notes. We are making a concerted effort to really make sure that everything that we mentioned in the show gets put into the show notes. So please go check them out. They're at biohmblog.com. That's BIOHM off of the BIOHM Health website and under the podcast tab. This episode has been powered by BIOHM Health. I'm Andrea Wien, and we'll catch you next time.